In this video, we're going to look at the nth roots and rational exponents. So the principal nth root, if a is a real number with at least one nth root, then the principal nth root of a, written as nth root of a, is the number with the same sign as a, that when raised to nth power equals a. The index of the radical is n, so this is index of the radical. So if it's a negative, then the answer is negative. So if you're doing like the cube root of -8, we have some examples here, but you get -2. Okay, so here's the cube root of -216. And that's going to be, so you think about, I mean, you can put this in your calculator, but that's going to be -6. Because 6 to -6 to the third power equals -216. Okay, for this next one we have 3 times the 4th root of 80 over the 4th root of 5. So I'm going to treat that as 3 times the 4th root of 80 over 5. So it's 3 times the 4th root of 16. So 3 times 2, which is 6. And then this last one here, we have 6 times the cube root of 9,000 plus 7 times the cube root of 576. So we need to think about what we can break out of here. And what jumps out at me is that 9,000 could be written as 9 times 1,000, where 1,000 does have a cube root of 10. So for 576, I put that in the calculator and divide by 9, I get 64, which is also a perfect cube. So what we have here is 6 times the cube root of 1,000 times the cube root of 9 plus 7 times the cube root of 64 times the cube root of 9. So that's going to be 6 times 10 plus the cube root of 9 plus 7 times 4 times the cube root of 9. So we have 60, I see an error right here, that should be times, 60 times the cube root of 9 plus 28 times the cube root of 9, so I get 88 times the cube root of 9. Okay. Move on to using rational exponents, excuse me. So rational exponents are another way to express the nth roots. The general form for converting between a radical expression and a radical symbol with a radical symbol and one with a rational exponent is a to the m is either the nth root of a to the m or nth root of a to the m. So notice in the first case the m is outside the parentheses, and in the second case it's under the radical. So these are equivalent terms though. So given an expression with a rational exponent, write the expression as a radical. This is how we're going to do it. Determine the power by looking at the numerator of the exponent. Determine the root by looking at the denominator of the exponent. Use the base as the radicand to the power and use the root as the index. So write 9 to the 5 halves as a radical and simplify. So this is like saying, so the 2 is going to be square root. So the square root of 9 to the 5th power. So that's like saying 3, square root of 9 is 3 to the 5th power. And let's see, what's that going to be? It's going to be, it's 243. Because 3 to the 4th is 81 times 3 is 243. Okay. The next one, write x times the square root of 5y to the 9th using rational exponents. So again, the square root symbol is an index of 2. So that's going to be x times 5y to the 9 halves. And number 13 here, which is the last one, it says simplify. We have 8x to the 1/3 times 14x to the 6/5. So in this, the x has that power. So we have 8 to the 1/3 x to the 1/3 times 14 x to the 6/5. Now 8 to the 1/3 is going to be the cube root of 8, which is 2. So this is 2 times 14, and we have our times x to the 1/3, x to the 6/5. 2 times 14 is 28, x to the, then we're going to add 1/3 plus 6/5. They have the same base, so we can add the powers. So 28 x to the, it looks like 15 is a common denominator. So that's going to be 5/15 plus 18/15. So it's 28 x to the 23/15. And I guess I'll leave it like that. Okay, hope that makes sense. And we will, now you can do the homework for this section. We'll move on to Chapter 2.